Welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3, Paper 3-2 for May, June 2024, and this is part 2 for questions 6 to 10. Question 6, the diagram shows the curve y is equal to x, then e power negative a of x, where a is a positive constant and its maximum point m. Part A, find the exact coordinates of m. Now, the fact that they have given us the nature of the point it is maximum, it is a stationary point. And for stationary points, the y dx is equal to 0. And then this one here is a product of two functions. So we are going to use the product rule. Okay, using the product rule. So we shall get our dy dx, which will be equal to, we keep this constant, the x, then we differentiate e to the power of negative ax, and then plus, now we keep e to the power of negative ax, then we differentiate with respect to x, this x here, then after we equate to 0 because this is a stationary point. Then you know that when we differentiate an exponential function, we just get that power, we differentiate it, then we get f prime. Then after we multiply all through by that exponential function. So that means here we shall have a negative a x, then e to the power of negative ax, because when you differentiate here you get negative a, then you multiply it through. Okay, then here plus, when of course we differentiate x with respect to x, we shall get a 1. So we have this one here, which is equal to 0. Now, on the look of things, e power negative ax is common. So when I pull it out, I'll get negative ax here, then plus a 1. Then this one is equal to 0. So meaning e to the power of negative ax is equal to 0. And this one is undefined because there is no number you're going to power this e with and then you end up with a 0. That's why we don't have natural log of 0. Okay, remember, a logarithm is that power you're going to raise a certain number to give another number. Okay, so there is nothing that you're going to power here and then it gives you a 0. Then this is the next one is negative ax, then plus 1, which is equal to 0. So 1 is equal to ax, therefore x becomes 1 over a. Okay, 1 over a. Then after getting that 1 over a, then we need to get the coordinates of y. So the y coordinate is going to be y is equal to, remember, it is x, then e. So we shall have 1 over a, then e power negative a times 1 over a. Of course, this one will cancel with this, then you get a negative 1. So meaning y is going to be 1 over a, e power negative 1. So the exact coordinates of m, I can write them as the x is 1 over a, then the y is 1 over a, then e. Because this one can go down. So whether you write it as 1 over a, then e to the power of negative 1, or you write it like this, they are all the same. So I'll conclude that these are the coordinates of m. Now here, part B, find the exact value of this integral here. You can see it is a product of two functions. So here we use integration by parts, and we use our acronym ILET. I've always told you what it represents. So this is inverse trigonometrical functions, this is logarithmic functions, this is algebraic functions, and we can see algebraic here. Okay, and then this one is trigonometric, then this one is exponential. Okay, so I'm using these two. This is algebraic, and then this one here is exponential. So the one which comes first is the one that we differentiate. Remember, one of the functions has to be differentiated, the other one integrated. So I will let my u to be equal to that x. So then what is du dx? It will be equal to 1. And then the dv dx, this is the one I'm supposed to integrate. it has to be e to the power of negative ax. Okay, then from there, we know that when you integrate e to the power of f of x dx, this one is equal to e to the power of that f of x. Then we shall divide by the f prime of x. Remember, when we differentiate e to the power of f of x, we just get the power, that f of x, we differentiate it, then we multiply it through. Now for integration, we divide it. Okay, so that means v here, which is equal to the integral of this one here. When we differentiate here, we get a negative a, so that means we shall get e power negative ax, then divide by negative a. But I can write the a here, and then I put this one as a negative, just like that. Then using integration by parts, so the integral of u dv dx with respect to x is given by uv, subtract the integral of v du dx with respect to x. So we shall have 0, then 2 over a, and then x here, e power negative ax with respect to x. This one is going to be equal to, what is our v? Our v is here, then our u is x here. So I can write negative x e power negative ax over a. And then we subtract the integral. Our v is negative e power negative ax over a. And then times du dx is 1, then dx. So this is 2 over a and then a. Then after that, we can write this one again here, out of a, then of course plus, then the integral. In fact, I can, this is a minus and a minus, so it becomes a plus. Then I can take out the a. Okay, so when I take it out, I can write something like this, 1 over a, then the integral of e power negative ax with respect to x. So like that. But again, already we know the integral of this one here. It is the one we got here. So we shall just put negative x e power negative ax out of a, then plus, this is 1 over a, then times negative e to the power of negative ax over a. Then we put our limits like that. So simplifying everything, in fact we can put the limits. So let's put 2 over a wherever there is x. So this is negative 2 over a. It will find the a which is down there, and then it becomes a squared. Okay, then e to the power of negative a, then times 2 over a. And then this one is a minus 1 over a squared. There's a minus here, then a times a. Okay, that's why I've written minus a, 1 over a squared. Then e to the power of negative a, then times 2 over a. Then after that we can subtract, then we put this lower limit. So we shall have here a, then e power negative a. This will be a squared, then over a. And then next we shall have, actually this is not an a, sorry, it is a 0. Everywhere I've been writing a, pardon me here, it has to be a 0. So 0, 0, 0. Now when we put 0, automatically here we shall have a 0, then minus. Now when we come back to this one here, when you put a 0 here, it is going to be e power 0. So we shall have 1 over a, then e, it is a squared, then e power 0, just like that. Now we can simplify. Here it will be negative 2 over a squared, then e to the power of course this one goes, so we shall get power negative 2, the same to this one here, e power negative 2, and then minus, of course, this one, now when we open the brackets, it will be a plus, so plus 1 over a squared. E power 0 is the 1, so we just have plus 1 over a squared. Okay, now 1 over a squared is common. Just trying to simplify. If I factorize it out, I'll get negative 2 e power negative 2, then minus e power negative 2, and then plus 1. So these ones are like terms. So minus 2 minus 1 gives us negative 3. Okay, so let me in fact write the final answer, 1 over a squared. Since this one is positive, so I'll write it as 1, then minus 3 e power negative 2. So I can write this as 3 over e squared. Okay, or you can write 3 e power negative 2. No problem, it's all the same. So this becomes our answer. Question 7 is coming from trigonometry part A. Show that cos power 4 minus sine power 4 is equal to cos 2x. Now, using a difference of two squares, this is one identity you must know, that a squared minus b squared, which is equal to a plus b, then times a minus b. This cos power 4 theta minus sine power 4 theta, it is the same as saying cos squared theta, then squared, minus sine squared theta, then squared. Now I can add them, so cos squared theta plus, now our a is this one, our b is that one, okay, the sine squared. So cos squared theta plus sine squared theta, and then cos here squared theta minus sine squared theta. When you look into the list of formulae, you will find that cos 2 theta is this one here, cos squared theta minus sine squared theta. So that is, and this one here is 1. So I will have our answer out as cos 2 theta, as simple as that. Alternatively, you can say, I can express cos in terms of sine. So if I have cos power 4 of theta minus sine power 4 of theta, I can either express sine in terms of cosine or cosine in terms of sine. So first of all, this is cos squared theta squared minus sine squared theta squared. So here I can say 1 minus sine squared theta squared, then minus sine, I can even leave it as power 4 of theta. Now when I open brackets here, I'll put a square on 1, so that will be 1, then 2 times 1 times negative sine squared theta, that one will give us minus 2 sine squared theta. Then square this one, it will give us sine power 4 theta, but remember there is minus sine power 4 theta, so this one cancels with this, and then 1 minus 2 sine squared theta. So cos 2 theta in terms of sine theta, it is going to be 1 minus 2 sine squared theta. Check the list of formulae, it is there. So that is 1 minus, I will just put cos 2 theta. Okay. Suppose we had expressed it in terms of cosine of theta. Okay. So this is another alternative approach. Many ways to do this. Let me just copy this first part here and then I put it just here. Alternatively, if we have that, then we can leave this one here, cos power 4 of theta minus, then 1 minus cos. So I want to express sine squared in terms of the cosine. So that is that. Now we also open the brackets. This is cos power 4 minus square 1, that is 1, then minus 2 times this times that, that will be 2 cos squared theta, then plus cos power 4 of theta. Now we can open the brackets and we see. So this one is going to be cos power 4 of theta minus 1, then plus 2 cos 2 cos squared theta, then minus cos power 4 of theta. So you can see that this one cancels with that, and then we shall remain with 2 cos squared theta minus 1, and this is the same as cos 2 theta. So just like that. So whichever way, all of those, you get the answer, and all are easy. Then they are saying hence, meaning begin from where you have stopped or find a way of using what you have gotten into this integral here. So we are going to have this integral here, negative pi over 8, then pi over 8. This is cosine of power 4 of theta minus sine power 4 of theta, then plus 4 sine squared theta cos squared of theta, and then the theta. This one is actually going to be the integral from negative pi over 8 and then pi over 8 here. This one we have seen that it is cos 2 theta, okay, from part A. So I will write here cos 2 theta and then plus, since this one is a double angle, okay, then there is also a double angle here for sine. It is the same as 2 sine theta cos theta then squared, okay, the theta, because when you square the 2 you will get this 4. You square the sine, you get sine squared. You square the cos, you get cos squared. You see? So meaning that we have now the integral of negative pi over 8, then pi over 8. So cos here 2 theta, then plus, this is sine squared 2 theta, the theta. Now when we see the even powers of sine or cosine, we are supposed to use the double angle for cosine, okay? So the double angle for cosine, it says that cos of 2 theta is equal to 1 minus 2 sine squared of theta. So if I make sine squared theta the subject of the formula, bring it this side, it is a positive, right? So cos 2 sine squared theta, which is equal to, take this one here, it will give you 1 minus cos 2 theta. So meaning that, okay, meaning that we shall have our sine squared theta, which is going to be equal to 1/2 into 1 minus cos of 2 theta. Now you can look at this theta here, but then here we have twice theta. So meaning if we have twice theta here we shall be having 4 theta, okay? So we are going to write this one as sine squared 2 theta is therefore going to be 1/2 into 1 minus cos of 4 theta. Now this is what we are going to use. Now we can substitute here. It will be the integral from negative pi over 8 to pi over 8, then cos of 2 theta plus 1 minus cos of 4 theta over 2, the theta. Now when we integrate, of course, this theta here is not just a theta, it is 2 theta. So when we integrate a cosine, we get a positive sign, okay? So we shall write here sine 2 theta, but you enter inside, you differentiate the angle, then you divide through. If it is differentiation, we multiply through. If it is integration, we divide. So this one will be over 2. Then plus, I can have this one is 1 over 2. So when I integrate 1 over 2, I'll get theta, then over 2, okay? Then here we have 1/2 cosine of 4 theta. So when we integrate cosine, of course we get a positive sign. So this will be sine of 4 theta. But then again, we shall divide by the 4. Okay. So we are going to have here minus sine 4 theta. Then over, there is that 4, but it will find the 2 that is here. Okay. So altogether we will write 8. And then we put the limits. This is pi over 8. And this is negative pi over 8. Now, let us insert the limits, and then we find our final answer. So here we shall have cos of 2, then pi over 8. It's not actually cos, it's a sine. So this one here is sine over 2, then plus, this will be pi over 16, because the 8 will multiply with that 2. Then minus, this will be sine of 4 pi over 8. So just like that. Then we subtract. We can put sine of 2 times negative pi over 8 over 2. Then plus, it will be a minus pi over 8. And then minus, now sine 4 times negative pi over 8. Then over 8 here. Like that. Okay. Let me extend this one here. Like that. Then next we can now simplify. This is pi over 4. Sine of pi over 4 is root 2 over 2. So we can have a half times root 2 over 2. Then plus, this is pi over 16 minus sine of pi over 2. This one will be pi over 2. Okay. So it is pi over 2, that is a 1. So, and there is an 8 here. Okay, right from here, which is over 8. So I'll have 1 over 8 here. And then we shall subtract. So here, sine of negative 45, it gives you negative root 2 over 2. So we shall have a half, then times negative root 2 over 2. Then here we have minus pi over 8. I can actually open the brackets right away. So, but let me just leave it. Then plus, this one is a minus here. Will it be a minus? It will be a plus, because sine of negative 90 is negative 1. Sine of a negative angle is equal to negative sine of that angle. So the negative will multiply with this one, then you get a positive. So we shall get 1 over 8. Then after that, simplify. This will be root 2 over 4 plus pi over 16 minus 1 over 8. Then you open brackets. This one is going to become a plus. So root 2 over 4 and then plus pi over 8. Then minus 1 over 8. Okay. Then after that, this is root 2, then root 2 over 4. So a quarter plus a quarter, you get a half. That means here I'll get root 2 over 2. Okay. Then next, I can go to the ones that have pi's. I need to have a 2 here. I mean a 16. And also here. Because remember, we put pi over 8. And there is a 2 here. So the 2 finds the 8 and they multiply. So pardon me there. So pi over 16 plus pi over 16 will give us 2 pi over 16, which becomes pi over 8. So plus pi over 8. And then negative 1 over 8 minus 1 over 8. That one becomes negative 2 over 8, simplified to negative 1 over 4. So this becomes our exact answer. Question 8 is coming from vectors. The points A, B, and C have position vectors, this one, and that, where O is the origin. The line L1 passes through B and C. Find a vector equation for L1. okay? It passes through B and C. So I may have my line here. It passes through, they said B is here, maybe C is here, and then it goes up to somewhere. So there is a point R on that line, which we don't know. Then there is an origin here. So we are supposed to go to R, okay? Now, it is like when you are getting out of your home, then you join the road here, that is at the B. Then you are going somewhere, but there is a place you know where you do a small stopover, okay? And then you go to your destination. But this distance BR, from here where you join your road to where you are going, okay, it is a certain distance from where you join the road and where you know where you always take a step over, okay? So that becomes the directional vector. The road is going this way. You see that? Now, we are going to have the BR. So I want to get OR, okay? I want to get OR. So my OR is going to be equal to OB, then plus BR, okay? But BR, I don't know it, but I have to multiply it with something that I know. So something times the BC that I know. So lambda plus the BC. So this BC becomes the directional vector. So how do we find B to C? If I want to go to this C, I will say BO, then plus OC. But this arrow is facing this way. Now this one is coming back this way. So it is the negative of that. So I will say negative OB, then plus OC. But without wasting time, when you're finding these vectors, you just say the last minus the first. So this will be OC minus the OB, okay? So OC is given as 8, 5, negative 3. And then OB is given as 5, then 2, and then 0. Because there is no K, that means it is 0 there. So when we subtract, this one is going to give us 3, 3, negative 3. Okay, just like that. And I can write it as this one, or I can even factorize it. You can see that a 3 here is common. 3, then 1, 1, negative 1. So I can take this one. So the directional vector will pull out the smallest. Okay, so I can write now our OB is 5, 2, 0. Then plus, I may say lambda, then the directional vector is going to be 1, 1, negative 1. Rather than this one, because it can be simplified. Remember, parallel vectors are the ones that can be expressed in terms of each other as scalar multiples, okay? So better you write this one here. So that is the equation for L1. Part B, the line L2 has this equation. Find the coordinates of the point of intersection of L1 and L2. Now, we will write the parametric equations of these two and then we equate them because they have the same x coordinate, y and z. So when you look at the first one that we are having here, the x coordinate is 5 plus lambda. You get this, then plus lambda times this, then 2 times lambda times that, okay? I mean plus lambda times that 1 and then the other. So we shall have here 2 plus lambda and then 0 minus lambda, so that becomes negative lambda. Then from there, this one will be equal to, how about for this one? It will be negative 2. You can see the I here, and then the 3 mu. So I will have this as negative 2 plus 3 mu. Then the next one is going to be 1 plus mu, and then 4 minus 2 mu. Then we equate them. I will have just these two, and then I solve them simultaneously. So negative 2 plus 3 mu, and then this is 2 plus mu, which is equal to 1 plus mu. Then we can subtract to eliminate the lambda. So this will be 3. And then negative 2 minus 1, that is negative 3. And then 3 minus 1, you will get 2 mu. So when you take this one, this other side, it becomes a plus. So 3 plus 3, that becomes a 6, and then 2 mu. Meaning when you divide all through by 2, mu becomes a 3. Okay, so I don't need to find the value of mu. I mean, to find the value of lambda, because I can substitute here. Either this is the point of intersection or this one here. So I will let the point of intersection be P. That means its position vector OP is going to be equal to, this is -2 times, it's a plus, then 3 times the 3 that we have gotten, then 1 plus 3. I'm substituting here where there is mu, okay? Then 4 minus 2 times 3. So this one will give us -2 plus 9. That one gives us a 7. And then 1 plus 3, of course, that is a 4. And then 4 minus 6. 4 minus 6, that one will give us a -2. So meaning the coordinates, this is a position vector. So if you leave it there like that, you're not going to get the final answer. So the coordinates of that point of intersection, if I let it to be P, then it is going to be 7, 4, -2, like that. So you write the coordinates horizontally, okay? That is that. Part C, the point D on L2 is such that AB is equal to BD. Find the position vector of D. Now, if D is on L2, then its coordinates must satisfy the equation of the line L2, okay? And the equation of the line L2 is here, which is this one here. So I'll take this as the coordinate of D, okay? So every coordinate that is on that line must satisfy that. So I'm going to have my OD, the position vector of D, is going to be equal to -2 plus 3 mu, then 1 plus mu, and then 4 minus 2 mu. Now, this mu can have different values for all of those points that are on the line. If it is 0, we have this part here, that coordinate. Then, if it is 1, you get another coordinate. If it is 2, like that, okay? Now, AB, just like we have looked at part B, you just get the last minus the first. So AB is going to be OB minus OA, okay? So we have our OB, which is 520, then minus our OA. What is our OA? So OA is here, -2, 1, 4. -2, 1, and 4. So this will be 5 minus -2, that will be a 7. Then 2 minus 1, that will be a 1. 0 minus 4, that will be a -4. Okay. Then we also need BD. So what is BD? We shall get OD. Then we subtract OB. So OD is this -2 plus 3 mu. And then 1 plus mu. Then 4 minus 2 mu. Then we subtract OB, which is 520. So simplified, -2 minus 5, that will be -7. So I'll write -7, then plus the 3 mu. And then 1 minus 2, that one gives us -1. So we'll have here -1, then plus the mu. And then 4 minus 0 is of course 4. So we shall have here 4 minus 2 mu. Now they say that AB is equal to BD. AB is equal to BD. These are lengths. So we need to find the length of this one. So it will be the square root of 7 squared plus 1 squared plus -4 squared. Then BD, you will get -7 plus 3 mu. You square it, then plus -1 plus mu squared, then plus 4 minus 2 mu. You square it, then even this one is under the square root. Of course, when you square both sides, that one will disappear. The square roots will go, okay, when you square both sides. Now, this is 49 plus 1. That is 50, then plus 16. That one gives us 66. Then we go this side, square this one, you will get the 49. Then 2 times 7, 14 times 3, that is 42. Okay, so I will have minus 42 mu. Then square this one, it will be 9 mu squared. Then square this one here, you will get a 1. Then 2 times this times that, you get minus 2 mu. Minus 2 mu. And then square the mu, that will be mu squared. And then square this one, that will be 16. Then 2 times 4 times negative 2, that one will give us, then that negative 16, yes, negative 16 mu. And then when you square this one, you get 4 mu squared. 4 mu squared. So we shall have this 66 here. Then this side, we have 49 plus 1 plus 16. It's also 66. So that means that 66 will cancel. Okay. Then this is 9 mu squared plus 1 mu squared. That will be 10 mu squared. Then plus the 4, that will be 14 mu squared. So we shall have 14 mu squared. And then after that, this is minus 42 minus 2, that is minus 44. Then minus 16, that one will give us 44 plus 16, that is 60. So minus 60 of mu. Minus 60 of mu. So this one will go. So what is common here? We have 14 mu squared minus 60 mu, which is equal to 0. So 2 mu is common. I can factorize this. And then we have 7 mu. Then minus, of course, this will be 30, which is equal to 0. So meaning mu can be 0 or mu can be 30 over 7. Of course, we shall take this one, because if we just take mu is equal to 0, then we shall remain with only this point here, the negative 214. Okay, and negative 214 is point A. So D has to be a different one. Now, OD, we can now substitute in what we are having here, what we got as our OD. Our OD is this one here. So, therefore, OD is going to be equal to, remember it is this one, so negative 2, then plus 3 times 30 over 7. Then we also have 1 plus 30 over 7, and then 4 minus 2 into 30 over 7. So then when we simplify this one, what do we get? Okay, now this is, you can get this 7 times this 2, you get negative 14, right? Then plus, this will be 90. So it is 90 minus 14, which is 76. Okay, so my OD is going to be, this will be 76 over 7. And then here 7 times 1, that will be a 7. Then plus 30, that will be 37 over 7. And then here 7 times 4, that is 28. Now 28 minus 60. 28 minus 60, that is a negative 32. So negative 32 over 7. So this is our answer here. That is the position vector of D. If you want, you can write it as 76 over 7I, then plus 37 over 7 of J, then minus 32 over 7 of K. And then you can say that is your OD. It is also okay. So either this one here or this one, they are all correct. Question 9 is coming from complex numbers. The complex numbers Z and omega are defined by Z, which is equal to 1 minus I, and then omega is negative 3 plus 3 root of 3I. Okay, then they are telling us to express Z omega in the form A plus BI, where A and B are real and in exact form. So the sides must remain there. So Z times omega is going to be 1 minus I. Then omega is negative 3 plus 3 root of 3I. So whatever is in the first bracket here must multiply with whatever is here. So that means I will have 1 times everything here will be negative 3 plus 3 root of 3i. And then negative I times everything, we shall have positive 3i, and then plus, it will be a negative, so minus 3 root of 3i squared. And in complex numbers, we know that I squared is always equal to negative 1. Okay, now that means this whole thing is going to become a positive. So we are going to have negative 3, then plus 3 root of 3i plus 3i, then plus 3 root of 3. Now I can separate the real from the imaginary. So the real, we have negative 3 here and this one here. So I can write it as negative 3, then plus 3 root of 3, then plus, this is the imaginary part. So it is 3, then plus 3 root of 3 of I. So that will be my answer there. Then part B, express Z and omega in the form r e power I theta, that is exponential form, where r is greater than 0 and theta ranges from negative pi to pi. Give the exact values of r and theta in each case. Like I've already said, before you find the argument of any complex number, first sketch and know where it lies. Okay, first sketch and know where it lies. Let me split this one into 2. Let us find where Z lies. So we have, is it in the first quadrant, second quadrant, third quadrant, fourth quadrant? It's very important. So this is imaginary of Z, this is the real of Z, and Z is 1 minus I. So 1 is positive is this side, then negative is down here. So Z will be here. Okay, so Z is going to be in the fourth quadrant here. So meaning its argument is going to be a negative. Okay, its argument is going to be a negative. So we shall say, but then you don't consider that negative here. This is just 1 unit. Take them as the lengths. Okay, this is 1 unit and this is also 1 unit. So tan of theta, because there we are using SOHCAHTOA, it's a right angled triangle. So tan theta is equal to the opposite over the adjacent. Okay, so tan of that theta is equal to 1 over 1. That means theta is going to be the arctan of that one, which is pi over 4. But since we are moving anti-clockwise, it is below the z-axis, it has to be a negative. Okay, if the complex number is in the first quadrant here, this one is positive, the gradient. If it is in the second quadrant here, it is also positive. Okay, we are moving anti-clockwise. If it is in the third quadrant and we move like this angle will be greater than 180, yet they say that it should not exceed what? 180. You see that? So that means instead of us moving like this, we then move like this. We move now clockwise. So it becomes a negative. You see that? And then in the fourth quadrant, we also move like that. So this one is negative pi over 4. Okay, so this one is pi over 4. Then how about the r of z? R of z here is going to be the square root. So we get this squared plus this squared under the square root to get the magnitude of the z there. Okay, so 1 squared plus 1 squared. In fact, I can say maybe the y is a negative. So like that, then we get root of 2. So this therefore implies that z is going to be equal to, its r is root of 2. And then e, let me shift this one a little bit down. Then e to the power of negative pi over 4, then I. Okay, remember we are moving anti-clockwise. This theta is a negative, so don't write your positive here. So that is our z. All right. In fact, I can just put the negative here. It's a negative, theta is equal to the negative arctan of 1, such that it makes that sense there. And then next, let us also sketch the one for z, for omega. So let me just copy this one here, and then I put it here. We also want to find out where this one is, where the omega is. So let me rub off this. Okay. Now omega is given as -3. So negative is on this other side for the real. Negative is this way. Let's say that is -3. And then we have 3 root of 3. So 3 root of 3 is actually where? Is actually up this way. So maybe that is 3 root 3. So it will be up here. Okay. So it is in the second quadrant. But this angle makes an angle here. Let's say it is alpha. The argument of this, so this complex number makes an angle of alpha with the horizontal, but the argument is going to be this other one here. That will be its theta here. And that theta in the second quadrant is got by getting 180, then minus the acute angle you have gotten there. So minus the alpha. Okay. Now, let us begin by finding this angle here. So this is 3 units, and this is 3 root of 3 units. So we shall have tan of alpha is equal to, the opposite is 3 root 3 over 3. And then that alpha is going to be equal to the arctan. Of course, this one cancels, and then you get root of 3. So root of 3, which gives you pi over 6. Pi over 3, 60 degrees. Then from there, the argument of omega, it is that theta, it is going to be equal to pi, then minus pi over 3. 180 minus 60, you get 120, which is 2 pi over 3. Okay. Then how about the magnitude? Okay, the magnitude of omega, which is going to be the square root of -3 squared, then plus 3 root of 3 squared. So what does this one give us? This is 9. Then 9 times 3, that is 27. So 27 plus 9, that is 36. Root of 36, this one becomes a 6. So meaning omega is going to be equal to 6, then e to the power of 2 pi over 3 of I. Okay, so that is that. If I try to, let's say, extend it down here. So this is going to be our exponential form for omega. Then part C, on an Gann diagram, the points representing omega, z omega, are A and B respectively. Prove that OAB is an isosceles right-angled triangle where O is the origin. An isosceles triangle must have 2 angles which are equal. The base angles of an isosceles triangle are equal. Okay, and we also have maybe 2 sides, they are equal in length. Now let us do something small here. Okay, we have A here represents omega, and omega was given as -3, then plus 3 root 3 I. So I will put 3 root 3. Okay, now what is this 3 root 3? 3 root of 3. This one is 5.196. Okay, this one here, 5.196. I'll need it somewhere. Then how about B? B is representing this one here, z omega. And for z omega, we got it up here. So the real is here, -3 plus 3 root 3. -3, -3 plus 3 root of 3. And then the other one is 3 plus 3 root of 3. Now let us see these coordinates here. What is this one and what is this one? Negative 3 plus 3 root of 3. This one gives us 2.196. 2.196. How about 3 plus 3 root 3? So I just come here and I change the negative. So this one gives us 8.196. 8.196. Then let's look at OA. Because this is isosceles, I need to prove the angles here. Okay. OA here, the length of OA, because A here represents this one here, which is the length or the magnitude of the omega, and we have seen it is 6. Okay, then how about AB? Okay, AB as a vector, this one is going to be OB minus, because remember these complex numbers are vectors, they are points in space. Okay, so OB minus OA, and this is 3, negative 3 plus 3 root of 3, that is the y, and then the x, or what we can call the real, is this, then minus, this is negative 3, then 3 root of 3. So when we subtract them, we shall get 3 root 3 here, because this is a negative, then plus this, so it just goes, and then 3 minus this, which also goes, no, we have this 3 root 3, then minus 3 root 3, so we shall just have a 3 down here. So if we try to get the length of AB, the length of AB is going to be the square root of 3 root of 3 squared, then plus 3 squared. So this is 27, then plus 6, 9, that one gives you 36, so root of 36 gives you 6. Now you can see that AB is equal to OA, so two sides are equal. Okay, but OB, which is the length of, if we look at the length of this one here, the ZW is represented by B, is not going to be equal to 6. Let's check it out here. If you get the calculator, we have square root, then we have negative 3 plus 3 root of 3, then I closed the brackets here, then squared plus 3 plus 3 root of 3, then also close square. This one gives us 6 root 2. So AB is 6 root 2. OB is 6 root 2. And yet these two have given us the same value, 6 and 6. So this is an isosceles one, triangle. Now let us sketch our Argand diagram. Okay, so here I can say hence isosceles. Okay, hence isosceles. So I will put my axes here. This is the imaginary, and then this is the real. Then we have one, so we plot the points here. Negative 3 is here, and then 5.196. So 5.196, it is above the 5. Okay, so when I bring it here, so I will have something like that there. So I will have this one as point A, okay, which is representing the omega. Then point B representing Z omega, 2.196. This may be around here, beyond 2, and then 8.196. So if this is my 2 going here, so I'll just put it somewhere there. I will have something here like this, just beyond the 8, and then something small beyond the 2. So this one here will be part B. Okay, part B. Now when I try to connect these points here, and this to that, and then this to this, then this to that. Of course, make them dotted. We are just supposed to put there the points. When I try to connect these ones here, because they talked of a triangle that is isosceles, you can see that we have already proved that AB is equal to the OA. This is our or the origin. These two are equal. This is a right angled triangle. Set a right angled triangle. Let's see. AB, we have seen it is 6. Then plus OA, we have seen it is also 6. So when we square them and we add them, then under the square root, do we get the OB? Remember, OB, we saw it. It was 6 root 2. I showed you on the calculator. So this one is actually the same as saying 36 times 2. That's what is inside here. So root of 36 is going to be 6, then times root of 2. So you can see that when you get this one squared plus this one squared, you actually get this one squared. And if they tell you to prove that this one here is right angled triangle, you have to prove this Pythagoras theorem, okay, on that diagram there. So this is going to be our sketch by just extending it there a little bit. So that is what we have. Actually, they told us to prove that it is an isosceles right angled triangle. See that? Right angled triangle. So what we have done before here is even in play. So I can actually also prove using the angles, okay? The angle here is going to be for ZW, the argument for ZW, because remember B represents ZW, okay? That angle here is for ZW. This is the argument for Z omega, sorry. And then from here to here, this one will be the argument for, it is omega, because A represents omega. Okay, that means to get this angle here, I will get this one here minus this. You get it? If it is 45, okay, then this other angle has to be a 45. Okay, because already we have seen that this length here is equal to this length here. So that means the angles which are opposite to them must also be equal. You get that? Okay. Now we have angle AOB. I've said it is equal to the argument of omega, then minus the argument of Z omega. So the argument of omega, if we can check here, is 2 pi. Okay, it is 2 pi over 3. We got it here. So 2 pi over 3. That is 2 pi over 3. Then minus this one here, Z omega. It is actually the same as saying argument of Z plus the argument of omega. Okay, when you use the properties of arguments, why is it like that? If I have, let's say for Z, it has its argument as theta, and then I write r e power I theta, and then omega has, let's say, r2, this is r1, then e power I, let's say, alpha. Okay, so when I say omega times the Z, I'll have r1 multiplied with r2, then using indices, this and this, the powers will be added. So you get theta plus this, then I. So do you see that the arguments are being added here? So that's why I've added them here. Or you can use this one here. You can use these two here to find the argument. So this will be 2 pi over 3 minus, now argument of Z is here. It's a negative, okay, it's a negative pi over 4. So when I come back here, I'll write negative pi over 4. It will be affected by this negative here, okay? Then also minus, in fact, this one will be our plus, and then minus the argument of w, omega is 2 pi over 3. Automatically, this one will cancel with this, and then we get pi over 4. And I told you that if we get this angle here as 45, then even this one has to be 45. You see? So, meaning angle AOB has to be equal to angle O, then BA, which is equal to pi over 4. So, therefore, that angle OAB is equal to 90, which is pi over 2. Then part D, using your answers to part B, prove that that is that. Now, we have said that argument, okay, argument of Z omega is equal to the argument of omega, then plus the argument of Z, okay? Now, this one for omega, it is 2 pi over 3, then minus, this one is pi over 4, okay? 120 minus 45, okay? Or we can simplify this one and say this is 12 here, then 12 divided by, then we can cross multiply these ones. So we have 8 pi, then minus 3 pi. So don't you get a 5 here? So that one is going to give us 5 pi over 12. So I'll have here 5 pi over 12. However, ZW means Z omega, we have it as negative 3 plus 3 root 3, then plus 3 root of 3 of I. Not so? Let's check again here. And we see. When we check, yes, negative 3 here, then 3 root of 3, and also the same here. Meaning that the argument here is going to be the arctan. Remember, it is arctan of the imaginary over the real. Argument of Z omega is going to be the arctan of this 3 plus 3 root of 3, then divide by negative 3 plus 3 root of 3, okay? So I can now substitute here. This one is now equal to that. So we shall have arctan of 3 plus 3 root of 3, then out of negative 3 plus 3 root of 3, which is equal to the 5 pi over 12. Automatically, you can take this turn this other side, and then here 3 is common. So if I divide the numerator and denominator by 3, we shall have 1 plus root of 3 over negative 1 plus root of 3. Then this will be equal to the tan of 5 pi over 12. And it is the same as this. So I can just write this first, then plus 1, then root of 3, then minus 1, like that. So this is our answer. Question 10 part A. By writing sec cubed as 1 over cos cubed theta, show that dy dx is equal to this. Okay. Now, when I'm doing this one, I'm going to say y is going to be cos of theta, then brackets power negative 3. Okay. Because cos cubed of theta is the same as cos theta, then cubed. Okay. This one here. Now you take it up, so the power becomes a negative. Okay. Now, when I'm differentiating this one with respect to theta, I will drop this power here. Then when I drop it, it's minus 3, then cosine of theta. Reduce this by 1, it will become a negative 4. Okay, then times. Enter inside here. You differentiate. When you differentiate a cosine, you get a negative sign. You see that? Then that means we are going to have a negative times a negative, that's a positive. So we have 3 sine of theta and then we divide by the cos power 4 of theta. This is the same as saying 3 sine of theta, then times 1 over cos power 4 of theta. Okay, and that is the sec power 4. So we shall have 3 sine theta, then sec power 4 theta. Then part B, the variables x and theta satisfy the differential equation. Here, it is given that x is equal to 3 when theta is equal to pi over 3. Solve the differential equation to find the value of cosine of theta when x is equal to 0. Give your answer correct to 3 significant figures. Now, here we are going to separate variables. Okay, so separating variables, there is always a mark here. Separating variables. Put x on one side and then the theta on one side. If I divide through by this, it will come this other side. Okay, then divide through by this, it will go this other side. So I will have sine theta over the cosine power 4 of theta d theta, then is equal to the x plus 3 out of x squared plus 9 of x. Here we use cross multiplication. Just cross multiply and then you divide accordingly. Okay, then from there we can now integrate. So integrating, what do we get? So I integrate this sine theta over, but do you realize that this sine theta over cos power 4 is the same as sine theta, then sec power 4 of theta d theta? Then you also integrate this other side here. And this is something that we have gotten before. Okay, now by looking at what we are having here, when we differentiate this, if you differentiate with respect to theta, this sec cubed theta, we got 3 sine theta sec power 4 of theta. That means I can first divide all through by 3. Okay, when I divide through by 3, I will get 3 here, then the theta of sec cubed theta. You see that? Then I can integrate both sides because I'm looking for this one here. Okay, now I can actually put this one here because this one is a constant. So when I differentiate this, I mean integrate this one here, check the integral sign here cancels with the derivative. Okay, because these are inverse functions. So meaning that actually this one is not a 3. We are dividing all through by 3. So it is going to be a third. Okay, so meaning when you integrate this one, it gives you a third of sec cubed. Okay, so I'm going to write a third here of sec cubed theta. Okay, that's why they told me to first differentiate it here, because it has to be applied in here when we are solving the differential equation. Then we can go this other side. I can split the numerator because I can see an x and then a constant. So I will integrate these ones differently. X over, this is x squared plus 9 with respect to x. Then we also integrate here 3 over 3x plus 9. So if you see an x here, when you differentiate this, it can be expressed in terms of that one. So that one is going to be a natural log. When I differentiate the denominator here, it is going to give me 2x. Now I ask myself, what should I do to this 2x to get that x there? I'll multiply it by a half. So this operation here that I've done on this derivative is what I put on the natural log. Okay, so meaning this one is going to be our a half. So here we shall have a half, the natural log of x squared plus 9. You see that? Of course, here we have a third sec cubed theta. Then after that, we can go to the other one. Now, we have this one here that if you integrate 1 over x squared plus a squared with respect to x, it is given in the list of family. So you get 1 over a, then the arctan of x over a. Okay. Now, this one here is the same as I can take the 3 out. Then I have 1 over, we have that x squared plus 3 squared. So do you see that our a is that 3? So meaning we are going to have something like this. So plus the 3, then times 1 over 3, then the arctan of x over 3. Then I can put that arbitrary constant because we don't know what disappeared when they differentiated. Okay, so we are supposed to find that arbitrary constant using the using what they gave us. So what did they give us as the initial conditions? X is equal to 3, then theta is equal to pi over 3. If x is equal to 3, then theta is equal to pi over 3. Now here I can have 1 over 3 times, this one is going to be 1 over cosine of pi over 3. Then after we cube, sec cubed is 1 over cos cubed. Okay, so we can first get the cosine of that theta and then you cube it. Then this one is going to be equal to a half. Then the natural log of 3 squared is 9, so plus 9, that will give us 18, natural log of 18. Then of course this one will give us a 1, and then plus the arctan. When I put this 3 here, it will be the arctan of 1. Okay, so plus the arctan of 1, then plus the c. So cos of pi over 3 is a half. So we have a third here, then times 1 over 2 cubed. This one is 1 over 8. So this one will somersault, and then we have 8 over 3. Okay, we shall have 8 over 3 here. You can just put everything in a calculator and you see. Then, of course, we shall bring this one this side. It will be a half. Then natural log of 18. And then arctan of 1 is pi over 4. Don't write 45. Write the answers in radians, not in where you have the arctan. Don't write the answers in degrees. You write them in radians. So this one will be now minus pi over 4. Now I will get this value here and then I put it here. That will be my particular solution. Okay, third, sec cubed of theta, which is equal to a half the natural log of x squared plus 9, then plus the arctan of x over 3. Remember, we had a 3 here times a third, so it disappeared. Then plus, we have gotten our c as 8 over 3 minus a half the natural log of 18, then minus pi over 4. So I'll have 1 over 3 sec cubed theta plus a half. Now this and this are natural logarithms, so I'll put them together and I will have, this is a natural log of x squared plus 9 over 18. Okay, because this one is common, so I factorize it, then there is a subtraction, so I divide the powers. Okay, then plus the arctan of x over 3. Then we shall have 8 over 3 here minus pi over 4. But they told us to solve the differential equation and find the value of cosine of theta when x is equal to 0. Then we give the answer to 3 significant figures. So the cosine of theta. For x equal to 0, we substitute here. We shall have 1 over 3 cosine. Remember, we are looking for cosine, so take away the sec. Then this one is going to be a half. Automatically, this will be 9 over 18, which is a half. So natural log of a half. And then plus, automatically, this one will be 0. Then we shall have 8 over 3, then minus pi over 4. So when we cross multiply, I can take this one here, then the cos cubed. So meaning I will have 1 over 3 will multiply with everything here. Okay, so we shall have a half, then the natural log of I can write this as 2 power negative 1. Okay, 1 over 2 is 2 power negative 1, then plus 8 over 3 minus pi over 4. Then this one will be equal to the cosine cubed of theta. Then from there, we take the cube root. So the cube root will give us the cosine of theta of 1, then divide by that. If I can bring this one here, it will be a negative. So negative half natural log of 2. But remember, there is a 3 which is multiplying everything here. So plus 8 over 3 minus pi over 4. Like that. So what will be our answer? So cosine of theta to 3 significant figures is going to give us the cube root. Then 1 divided by, we have 3 here, multiplying negative 0.5, then natural log of 2. Then after that, we shall have plus 8 over 3, then minus pi out of 4. Then we close the brackets. And then this one will give us 0.601 to 3 significant figures. 0.601 to 3 significant figures. That is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.